Hi again, Fernando here again, welcome to my channel. Now I want to give you another exercise corresponding to this topic of matrices. You can be very proud of yourself because you can see that the thermometer is in green color, which means that we are dealing with typical exam exercises. So let's read together the statement to solve it. It says, given the matrix A, and there you can see that it's an order 3 square matrix, but be careful because you can see that there is a little parameter inside. Section A. Study the range of our matrix depending on the values of the parameter A, right? Second section, for which values of A does the inverse of our matrix exist? And then we have to calculate the inverse for A being 1. So if you consider that you can tackle it, please go ahead, stop the video, and I will put the minute of the solution in the comments box. But if you consider that you cannot do it, please follow me because it will be a pleasure to do it together. Let's go.
Binnacle project.
Let's solve the first section. Look, we have an order 3 square matrix, So that's why we are going to calculate its determinant. We are using vertical bars, and let's write the matrix. Negative A, 0, A minus 1, 0, 0, A plus 2. And why are we going to do it? We are calculating this determinant, and we will set it equal to 0. And we will solve for A. Please follow me. Let's do negative A multiplying A minus 1 multiplying A plus 2. Now we are moving to the upper right corner. 0 times 0 times 0, 0. And now A multiplying A and A, that is A cubed, right? Second bit. Now we are doing 0 times A minus 1 times A, 0. And now we are moving upper to the left, and it's time to do A times 0 times A plus 2, 0 again. And finally, we are doing negative A times 0 times A, 0 again. This is the value of our determinant, but let's clean it up. We can leave negative A here, and let's multiply these 4 terms. A times A squared. A times 2 is 2A. Negative 1 times A is negative A. And finally, negative 1 times 2 is negative 2. And don't forget, plus A cubed. We are almost there. Now it's time to multiply negative A. There you can see what we are going to do. Negative A times A squared is negative A cubed. Negative A times 2A is negative 2A squared. Third, negative A times negative A is plus A squared. And finally, negative A times negative 2 is 2A positive. And don't forget A cubed. And you can see that we can cancel these two terms and clean these terms as negative 2 plus 1. Negative 2 plus 1 is negative A squared plus 2A. And this is the value of our determinant. And as I told you previously, we are going to set it equal to 0. And we are solving this equation for A. This is a second degree equation, so we can take out common factor, and we have A multiplying negative A plus 2 equals 0. where we can see that one solution is A0, and the second solution comes from doing negative A plus 2 equals 0, where A equals 2. 0 and 2 are the values of the parameter A that makes our determinant equals 0, right? And now follow me in this argument. If we have an order 3 determinant, which is equal to 0 when the parameter equals 0 and 2, for 0 and 2, our matrix doesn't have range 3, right? I repeat. For 0 and 2, our determinant, our order 3 determinant, equals 0. So for the parameter being 0 and 2, our order 3 matrix doesn't achieve range 3. Please think about it, and we are going to write the following. For our parameter A being 0 or 2, the range of A is not 3. Is not 3. Perhaps it would be 2 or 1, but not 3. And on the contrary, for our parameter different from 0 or 2, the range of A equals 3. And this is the most important thing that we have for this section. As I ran out of space, I've wiped the previous calculations. But what's going to happen if the parameter equals 0? Let's see. If A equals 0, we're going to write our matrix with the parameter being 0, that is 0, 0, 0, 0, 0 minus 1 is negative 1, 0, 0, 0 again, and 0 plus 2, 2. This matrix doesn't have range 3, okay? This matrix doesn't have range 3. But does it have range 2? We are going to do the following. If we are capable to find a little order 2 determinant different from 0, this matrix will have range 2. We are trying to find a little order 2 determinant different from 0, and in that case, our matrix will have range 2. Let's do it. Of course, I search for positions different from 0, and there you can see that if we write this little determinant, this little order 2 determinant, which is different from 0, negative times 2 is negative 2. So now it's official that for our parameter being 0, our matrix has range 2. And finally, what's going to happen if the parameter equals 2? Let's do the same. Let's write our matrix. If A equals 2, let's write our matrix with the parameter being 2. That is negative 2, 0, 2, 2, 2 minus 1 is 1, 0, and 0, 2, 2 plus 2 is 4. Again, this matrix doesn't have range 3. This matrix doesn't have range 3. But does it have range 2? If we can find a little order 2 determinant different from 0, this matrix will have range 2. Let's go ahead. Just try to find a little determinant of order 2 different from 0, and this one, 2, 1, 0, 2, which equals 4, different from 0, means that for the parameter being 2, our matrix has range 2. So here you have the solution for section A. For the parameter different from 0 and 2, the range of our matrix is 3. But if the parameter equals 0 or equals 2, the range is 2. That's it. And now let's do together the B section, which says, for which values of the parameter does the inverse exist? This is a typical question. It's very easy. Look. Can you remember that this is the formula that we use to calculate the inverse of a matrix, right? And can you see what appears in the denominator? The determinant of our matrix. You can see that in mathematics it is forbidden to divide by 0. So, for which values of the parameter this determinant equals 0? We did it in the previous section. For a equals 0 or a equals 2. For these two values, the inverse of a doesn't exist. I'm speaking slowly because I want you to master these typical arguments that are always the same. Don't forget, our determinant equals 0 when the parameter equals 0 or 2. So you can say that for the parameter being 0 or 2, the inverse of our matrix doesn't exist. And finally, we are asked to calculate the inverse of our matrix if the parameter is equal to 1. So what are we going to do? Just let's bring matrix A when the parameter equals 1. That is -1, 0, 1, 1, 1 minus 1 is 0, 0, 0, 1, and 1 plus 2 is 3. We just have to calculate the inverse of this matrix, which precisely it does exist, as the parameter is equal to 1, but not 0 or 2. Well, we are going to use this formula. Don't forget it, try to grab it in your mind. And the first thing we're going to do is to calculate the determinant of our matrix when the parameter equals 1. Of course, you can put here vertical bars in order to calculate the determinant. But can you remember that in the previous section, the determinant of A was -a squared plus 2a? And why don't we use this expression and substitute a for 1, and we will have directly the result of the determinant, that is -1 plus 2. 1. Of course that you can put this matrix between vertical bars and calculate the determinant, but I tell you that this is another very fast way to do it. As I ran out of space, there you have the previous calculation, and now we are going to calculate the adjugate matrix of our matrix A. And I guess that you already know how to do it. It will be also an order 3 matrix. First position, row 1, column 1. Let's eliminate row 1 and column 1, and let's do this little determinant, this order 2 determinant. 0 times 3 is 0, minus 1 times 0 is also 0. There you have an entire line of zeros. So the result is obviously 0. Second position, row 1, column 2. Row 1 and column 2. 1 times 3 is 3, minus 0 times 0, 0. 3 minus 0, 3. Now, row 1, column 3. Row 1, column 3. 1 times 1 is 1, minus 0. That is 1. Row 2, column 1. Row 2, column 1. That is 0 times 3 is 0. Minus 1 times 1 is 1. 0 minus 1 is negative 1. Now let's do row 2, column 2. Row 2, column 2. Negative 1 times 3 is negative 3. Minus 0. Negative 3. Now, row 2, column 3. Row 2, column 3. Negative 1 times 1 is negative 1. Minus 0. Negative 1. Row 3, column 1. Row 3, column 1. Can you see these interlines of zeros? So the determinant is 0. Row 3, column 2. Row 3, column 2. Negative 1 times 0 is 0. Minus 1 times 1 is 1. 0 minus 1 is negative 1. And finally, row 3, column 3. Can you see again this intercolumn of zeros? So the determinant is 0. Do you think that we have already set up the adjugate matrix? I'm afraid this is still not the adjugate matrix. What are we going to do? We are going to use the snake. Positive, negative, positive, negative, positive, negative, just like a snake. When I say positive, the number keeps its sign. But if I say negative, I will change the sign, okay? Positive, negative, positive, negative, positive, negative, positive, negative, and positive. Now, here you have the adjugate matrix of A. And finally, we just have to put the solution, the inverse of A equals the adjugate matrix, but transposed. Don't forget this little big detail. We are taking row 1 and let's turn it clockwise to put it in the form of column. 0, negative 3, 1, but in column. 0, negative 3, 1. 1, negative 3, 1, but in column. 1, negative 3, 1. Finally, 0, 1, 0 in column. 0, 1, 0 in column. Divided by 1, which means that if you divide by 1 all these 9 positions, of course, that you have the same matrix. 0, 1, 0, negative 3, negative 3, 1, 1, 1, 0. We have already finished this exercise. If you have come directly from the statement, I hope you got it right. And if you have done this exercise with me, I hope you've understood the setup and the solution. See you in the next exercise. Rock and roll! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!